Hello everyone, my name is Dilmin, and in this video today I will be discussing with you the topic gravity and gravitation. Okay, so you might be wondering, why is she telling gravity and gravitation? Both appears to be similar only. Then what is wrong with this woman, right? Okay, so the thing is that actually the topics gravity and gravitation, they have some dissimilarities, some similarities. Okay, let's see what the similarities and dissimilarities we are. So all of you might have heard a very common story about the apple falling on top of the head of Isaac Newton, right? So let's go over to that story once again. So the common story that is said to us many a times, it's something like this: that Isaac Newton was sitting under an apple tree wondering something, and suddenly an apple fell on top of his head, right? And then boom, the law of gravitation and all other things, like, it popped out of his head, right? But actually it's nothing like that. It's a little bit different. So as we are having COVID everywhere around us now, and situation is not so normal, we can say. So the thing is that during that time also there was a mahamari, or a epidemic, which we can say, that's called plague. Okay, so Isaac Newton was actually studying in his house, in his room, and then with his friends, obviously, I suppose. And then what happened is that he just came out and opened his window, and then he was getting trying to get some relaxing moment, and then he saw an apple falling from a tree. And since he was a very curious student, it led him to thought, like, why did an apple fell down? Why didn't it fall anywhere else? Okay, so, and in that way, slowly and gradually, we at present, we came up, we were bestowed by him with the law of gravitations and many other laws of motions and everything. And we actually should be grateful and thankful to him, because at that time, I don't think there were much technologies or scopes as we have now. Yeah, so that man have given us certain epic concepts, and due to which we are able to invent technologies and utilize and use science to the maximum extent, na? So we should be actually grateful to persons like him. Okay, so let me come first to the very basic thing. Okay, like, what is gravity? Difference between gravity and gravitation. So all of us know that earth have a certain pull towards its center. So whatever we throw, wherever we throw, everything ultimately comes down. Whether you jump from the top of a building, or you do skydiving, or you do anything, like, you have a tendency at the end to come down only, right? So the pull of earth of to any object towards its center, that is known as gravity. And what is gravitation? According to Newton, that there is a universal force. Now what is that universal force? That universal force is something which is on every object, and every object attracts every object. Okay, that is known as the gravitational force. And the pull of the earth of for other bodies towards its center, that is known as gravity. Okay, that is something that is the difference which Newton has given to us, that gravity and gravitation are two different concepts. Okay, now the thing is that Newton gave us universal law of gravitation. We will deal with that, but I would like to share one more thing with you all, that every object there is a gravity, from the term gravitation, like every object in the universe attracts every other object. There is an attracting force. So there are many planets in the solar system. Every planet moves on around the sun in its own orbit. Revolution happens, right? So then why don't, if every object attracts every other object, then why don't the planets collide? There should be collision, na? Attraction force is there among everyone. Now, let me come say to you. We have come across a law given by Newton, with the concept regarding motion. F is equal to ma. Now, if I try to find out acceleration from that form, F is equal to ma, so A is equal to what? It will be F by m, right? A is equal to F by m. That means acceleration is inversely proportional to mass. Acha. Chalo. We are human beings. We live on Earth. So we get a pull up from Earth every now and then. Then every now and then everybody should collide with one another, whoever is present. But we don't. Why? Why? Because the mass of Earth is much, much, much more than us. Right? And whenever the mass is more, acceleration will be less. Whenever the mass is less, the acceleration will be more. Okay, so that was one thing. Now we will come to Newton's law of gravitation. What was Newton's law of gravitation? Just hold on for a second. So I have prepared something. So can you see two objects, M1 and M2? Now one is a bigger object and another one is a smaller object. So what is this M1? M1 is the mass of the first body and M2 is the mass of the second body. And they are separated by a distance d. So what is Newton's law of gravitation? He stated that every object in the universe is attracted to every object, and there is a force acting on the objects which is directly proportional to the product of the masses of the two bodies and is inversely proportional to the square of the distance between them. Now what did he say? That there is a force which is acting on bodies, and that force is proportional to the product of the masses. Now what are the masses of the two bodies? M1 and M2. So product of M1 and M2 means M1 into M2. So first equation is according to his first statement, F proportional to M1 into M2. Force is directly proportional to the product of the masses of the two bodies. Now the two bodies are separated by the distance d. So he stated that the force is inversely proportional to the square of the distance. So if I square the distance d, it will be d square. Inverse of d square is 1 by d square. So the force is proportional to 1 by d square. So we have marked this as equation 1 and equation 2. Now if we combine the two equations, what are we going to get? Force is proportional to m1 into m2 divided by d square. Now to remove the proportionality sign, we need to put in a constant. So what is that constant that is used? F is equal to g m1 into m2 divided by d square, where g is the universal gravitational constant. Okay, so this was all about Newton's universal law of gravitation. In case if you have any doubt regarding this topic, please feel free to ask me. I'll try my best to help you out, and then we will start with the next one. Okay, bye bye and have a nice day. Take care.